My dear students, today I am with the question which was asked in the JEE Main exam. And the question is a solid sphere of radius r made of a soft material of bulk modulus K is surrounded by a liquid inside a container, a cylindrical container. A massless piston floats over the top surface of this cylinder, covering the entire cross section of the container. When a mass m is placed on the surface of a piston, liquid gets compressed. We have been asked here, what is the fractional decrease in the radius of this sphere? So let me show this thing here. The question asks, what is the fractional decrease in the radius of a solid sphere? So suppose this is a cylindrical container. Okay. This cylindrical container is filled by a liquid. Okay, fine. We have a solid sphere made of a soft material. So suppose this is a solid sphere, okay, having radius r. So this solid sphere is surrounded by a liquid. So this is a solid sphere. Solid sphere of radius r, bulk modulus K. Okay. So this is a container, cylindrical container, and this is a liquid inside it. Okay, fine. Now, according to question, a massless piston, we have a piston floats on the top surface of a cylinder. So suppose this is a massless piston. It floats on the top surface of this liquid. So this is a piston, massless piston, covering the entire cross section of the cylinder. Now the question asks here, when a mass is placed on the top surface, when this mass is placed on the top surface of this piston, or simply on the surface of this piston, what happens? The liquid gets compressed. Obviously the liquid gets compressed. So liquid gets compressed, and we have been asked here, what is the fractional decrease in the radius of this solid sphere? So that means the question asks, we people, the fractional decrease dr by r, what is its value? The fractional decrease in the radius of this solid sphere when a mass m is placed on the top surface of this piston, as a result of which what happens? The liquid gets compressed. So when the liquid gets compressed, there is the decrease in the radius of this solid sphere, as it is made of the soft material. So we have been asked here, what is the fractional decrease in the radius of this solid sphere? So let us look for the solution. The solution is this. As we know, my dear students, already I told you people, we know the bulk modulus of elasticity K, it is equal to minus P. So P here represents the pressure, divided by delta V by V, change in volume for the original volume. So volumetric strain. Now, in magnitude, the bulk modulus of elasticity is simply equal to P divided by delta V by V. Since we know what is the volume of this sphere, the volume of this sphere is 4 by 3 pi r cube. So volume of this solid sphere is 4 by 3 pi r cube. Now differentiating this, so it is dV over dr, it is simply equal to 4 by 3 pi. So differentiating r cube, it is 3r square. So therefore from here dV is simply equal to 4 by 3 pi into 3 into r square into dr. So 3 and 3 here cancel. So dV is equal to 4 pi r square dr. Okay. Now therefore dV by V. So therefore dV by V, it is equal to 4 pi r square dr divided by 4 by 3 pi r cube. So 4 and 4 cancel out, pi cancel out, r square and the r square will go here. So therefore dV by V, the volumetric strain, it is simply equal to 3 dr by r. Okay. Therefore, bulk modulus of velocity K, as you know already, it is P divided by dV by V, the volumetric strain. So K is simply here equal to P, the volumetric strain, it is here 3 dr by r. So just replacing dV by V by dr by 3 times dr by r. So we have been asked here to calculate the fractional decrease in the radius of this sphere. So simply it is dr by r, it is equal to P divided by 3 times K. Now you people know the pressure is force by area. So continuing this thing here, as we know, dr by r, so it is simply equal to the pressure, it is force per unit area divided by 3 times the bulk modulus of velocity. So simply it is equal to F divided by 3AK. By dividing this one and it goes reciprocal, so 3AK. Okay. So therefore the change in the radius of a solid sphere dr by r is equal to, now force F, the external force you people know, it is equal to mg. So we have a mass on the surface of this piston, therefore the weight on this piston is mg. So this weight is a force with which the piston moves downwards, and there is an increase in the pressure on the liquid, as a result of which there is the decrease in the radius of the solid sphere. So F is here equal to mg divided by 3AK. So this is your correct answer. So the correct answer is this: the fractional decrease in the radius of the solid sphere is mg divided by 3AK. This is the question which was asked in the JEE Mains exam.